Hi, and welcome to ChemSat, SAT Level Chem Explained. Today, we will be covering the topic of phase change, which is an integral part of chemistry. First, I want you to imagine a glass of water. Now, because it's summer, you're going to add some ice to that water to make it cooler. Then, I want you to imagine your bathroom mirror, and it's all fogged up because you've just taken a shower. And of course, you can't resist drawing a little smiley face there. Now, these are two everyday examples of water, H2O, going from one phase to another phase. In the first example, the ice went from solid phase to liquid phase as it melted, and in the second, the steam went from vapor phase to liquid phase as well. Now, as we know, there are three phases: the solid phase, the liquid phase, and the vapor phase or gas phase. Now, the transitions between these all have special names. Solid to liquid, for example, is known as melting. That's the solid ice in our glass of water turning into liquid water. Now, liquid to vapor is known as vaporization. That's the steam coming out of the kettle when you're heating up water to make tea or coffee. Now, the other way around, vapor to liquid, that is known as condensation. That's the steam from your shower, the water vapor, condensing on your mirror to form liquid water. Now, liquid to solid, that's known as freezing. That's when you put water in an ice tray and you cool it down and it becomes solid. There's one last transition, and that is solid straight to vapor, bypassing the liquid phase, and that is known as sublimation. These transitions from phase to phase require a lot of energy. So I want you to imagine a helicopter. Now, this helicopter is stationary. It's not moving at all. And we're going to compare that to the solid phase. Now, the helicopter has another phase, as we like to call it, and that is flying, and we can equate that to the liquid phase. Now, in order to make that transition from the solid to the liquid phase, or stationary to flying, we need to apply energy to the system, or energy to the helicopter. Now, how we do that to the helicopter is by applying energy to the propellers so they start to spin, which is the first step towards takeoff. We do the same thing to go from solid phase to liquid phase. We apply energy to make that transition. And in this particular case, solid phase to liquid phase, we would call that melting. So as we apply more and more energy to the helicopter, the propellers spin more and more, creating lift. And eventually, this results in takeoff, which is the transition from being stationary to flying. Now, similarly, after we apply enough energy to something in the solid phase, it undergoes that transition, it takes off into that liquid phase. So why is this relevant? Why do we care about this concept? Is there some sort of application, some way we can actually use this? The answer to that is a big fat yes. As with a lot of concepts in science, we can use calculations to get some form of information out of them. Now, the most common formula we use for this topic is Q equals ms delta T. Now, what does that even mean? That's just a bunch of random letters and symbols. But really, it's quite simple if we just break it down. Now, let's first take a look at this funky-looking delta T at the end of the whole thing. This means temperature change over a given period of time. If we think back to that original glass of water that we added ice to, we can assume that it was initially room temperature, and that's our initial temperature, which we denote as Ti. After we add the ice, we added it to cool it, right? So it gets colder. And after a given period of time, we have our final temperature, which we denote as T subscript F. Now, the way we find delta T to plug it into our whole formula is by subtracting the initial temperature from the final temperature. That's Tf minus T subscript I. Next we have S, and that stands for specific heat. And the specific heat of a substance is the amount of energy in joules required to change the temperature of 1 gram of the substance by 1 degree Celsius. Now we get to the easiest part, M. And all that stands for is the mass of the substance that you're given in grams. And now we're left with Q, which is probably the most complicated of all 4 of them. And it's the product of your mass, your specific heat, and your delta T, your temperature change. And what it stands for is enthalpy change, or put more simply, heat transferred. Now, one of the most important ideas to remember when doing problems with phase change is that Q lost is equal to negative Q gained. So what does that even mean? That doesn't really seem to make sense. Well, I want you to imagine 2 guys, and they're friends. One is named Joe, and the other is named Bob. Now, Joe has $3, and Bob has none. He's broke. And so Joe decides to be a good friend and gives his friend Bob $2. So Bob is excited, but now Joe only has $1 and Bob has 2. So now we can think of what Joe has given Bob as the Q lost, and what Bob has gained from Joe as the Q gained. So now Joe, in addition to his $1, has negative $2 since he gave those to Bob, and that's our Q lost. And now our Q gained are the $2 that Bob had received from Joe. So we'll write in that 2, but we have to remember to put the negative sign, just like the formula tells us. And now we can see that those 2 quantities, negative 2 and negative 2, are equal. As always, thank you so much for watching. I hope you learned something new. Go check out my second video on phase change, where we start to do some problems that apply the concepts we covered in this video, only on ChemSat.